Hello! Today we're going to be sketching graphs of functions. We're going to be focusing on some examples of very common functions that we will see over and over again. And it's important that the graphs you sketch today, that you do a very good job of making them accurate, and that you use graph paper and you keep them, because in the next lesson we're going to be using these graphs, we're going to be looking back on them, and we're going to be reading information off of the graphs that we've drawn. So very important that you do extra beautiful graphs. We're going to go through 6 examples in this lesson, so let's dive in. For each one, the instructions will be sketch a graph of, and then each one will have a different function. We're going to start with f of x equals x squared. This is just like y equals x squared. It's a graph that we've seen several times, but I want to do another one just so that we've got a very clean copy of it. So for our x values, I'm going to pick -3, -2, -1, 0, 1, 2, and 3. And then for the y values, all we're doing is taking x and squaring it. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now let's sketch this graph. Going point by point, we've got -3, 9, which is just above the template that we've got. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And of course, we know this is a parabola because it's the graph of a quadratic equation. So here we've got f of x equals x squared, a graph we've seen before. It's the first time we're seeing it as f of x, though. Before it was y equals x squared, but the f of x functions just as y does, and we have our graph. Let's do another one. The next one we're going to look at is going to be g of x equals x cubed. Again, we'll use x and y for our table of values. This time I'm going to do fewer values, -2, -1, 0, 1, and 2. Now when we cube these numbers, -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. Let's sketch this graph. All right, we've got -2, -8, -1, -1, 0, 0, 1, 1, and 8, 8. I believe we've seen this before. This is a smooth curve, just like the last one. But instead of going up in each direction, it's going up to the right and down to the left. And in fact, if we compare this with the parabola above, it's actually skinnier. It's rising much, much, much more quickly and closer to the y-axis than the one above it. So both of these are important graphs. We're going to see these probably over and over again. And so it's just important to me that you've got a good copy of each of these, that you know what they look like, so we can use these graphs moving forward. We're going to do one more example in this video, and then the next 3 examples in the next video. This time, let's look at h of x equals the square root of x. All right. Now, I'm going to be careful about the x values that I pick here, because I want to pick values that have a nice square root. So for example, I'm going to pick 1, 4, and 9. We can take the square root of all of those fairly easily. I'm going to pick 0. We can take the square root of that pretty easily. The problem is, if we try a negative number, we cannot take the square root of a negative number, at least not unless we're dealing with imaginary numbers, and with functions we're not. So that's going to be undefined. So we can't pick any other negative numbers. I will also pick a number that's not a perfect square. Let's do 7. Now, this function takes the square root of x. So when we take the square root of 1, we get 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 0 is 0. And the square root of 7 is 2 point something. It is approximately 2.6. Now let's pull up an xy plane and try to sketch the graph of this function. I'm going to use a slightly bigger xy plane just because this is a new graph for us. We haven't seen this yet this semester. Now, plotting these points, we've got 1, 1, 4, 2, 9, 3, 0, 0, and then 7, 2.6 or so. All right. Now, if we start from 0 and move our way up and over, we end up getting something like this. But we're not going to have anything to the left of 0, to the left of the y-axis. Because if we try to take the square root of any negative number, it ends up being undefined. So there's not going to be any graph over here. And there's not going to be any graph down here either. Some of you might be thinking that this looks like part of a parabola, and maybe it will continue down below. However, if we look at the function, the square root of x, when we use this radical, this means we're looking at the principal square root, or the one that's not negative. So we can't end up with any negatives down here when we use that symbol. So this is going to be the entirety of the graph of the function h of x equals the square root of x. I'm going to label the other ones as well. G of x equals x cubed. F of x equals x squared. And it's very important that you keep good copies of these graphs because we're going to be referring back to them in the next lesson. But for right now, I'd like you to go to the next video where we're going to go through 3 more graphs.